Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the process synchronization in operating systems. Process synchronization. Processes can execute concurrently. It may be interrupted at any time and partially completing executions. The concurrent access to share the data may result in the data inconsistency. Maintaining the data inconsistency requires the mechanism to ensure that orderly execution of the cooperating process. The illustration of the problem is, suppose that we want to provide a solution to the consumer producer problem that fills all the buffers. We can do so by having an integer counter that keeps track of the number of full buffers. Initially, counter is set to 0. It is initial, and then the producer, after it produces a new buffer, and it is decremented as a consumer after it consumes the buffer. Here we have a coding for the producer and consumer problem. First one is while loop. Here the condition is true, that is while counter is equal to buffer size, that is buffer in is equal to next produced, and in is equal to n plus 1. Here we uses the incremental of the buffer size and counter plus for this producer one, and for the consumer we uses the counter is equal to 0, while here we use the buffer as out is equal to out plus 1, and the buffer size counter is minus, that is here for consumer we uses the decremented one. Next one is critical section problem. Consider the system of the end process, that is P0 to P1 up to the Pn minus 1. Each process has a critical section segment of the code. Process may be changing common variables, updating table, writing file, etc. When one process in a critical section, no other may be in the critical section. So critical section problem is to design a protocol to solve this problem. Each process may ask the permission to enter the critical section, may follow the critical section with the exit section and then the remainder section. Here we have the general structure of the process PI, that is Q. First one is entry section, followed by the entry section we have the critical section, and then exit section. After the exit section we have the remainder section, then while condition is true. The solution to the critical section problem we have, first one is mutual exclusion, that is if a process Pi is executing in its critical section, then no other process can be executing in the critical sections. Second one is progress. If no process is executing in the critical section and there exists some process that wish to enter the critical section, then the section of the process that will enter the critical section next cannot be postponed indefinitely. Third solution is the bounded waiting. A bound must be exist on the number of times that other process are allowed to enter their critical section after the process had made a request to enter a critical section and before the request is granted. Here we have the two approaches depending on if the kernel is primitive or non-primitive. Primitive allows the presumption of the process when running in the kernel mode. Next one is non-primitive, runs until exit kernel mode, blocks or voluntarily yields the CPU. Next one is synchronization hardware. Many systems provide the hardware support for implementing the critical section code. That is first one, all the solution below based on the idea of locking. That is protecting the critical sections via the locks. Second one is uniprocess that could disable the interrupt. That currently running code would execute without the presumption, generally too inefficient on the multi-process systems, operating systems using this not broadly scalable. Third one, modern machines that provides a special atomic hardware instructions, that is atomic is equal to non-interruptible. Either the test memory word and the set value or the swap contents of the two memory words. Next one, here we have the solution for the critical section problem using the logs. Do acquire the log and then critical section, then it releases the log and then remainder section while the condition is true. Last one is the mutex logs. Previous solutions are complicated and generally inaccessible to the application program. So OS designers build the software tools to solve the critical section problem. It is the simplest mutex logs, that is product a critical section by first acquire the system call a log and then releases the log. The boolean variable indicating if the log is available or not. Thank you.